Today, I will be discussing hydrohalogenation of alkenes. Hydrohalogenation of alkenes involves the addition of a hydrogen halide, HX, across the double bond of an alkane. The hydrogen halide could be hydrogen bromide, hydrogen chloride, or hydrogen iodide. To predict the product of this reaction, there are two factors one needs to consider. The first one is regiochemistry, and the second one, stereochemistry. The regiochemistry of this reaction will follow Markovnikov addition rule, which states that the halogen X will be placed on the more substituted carbon, while the hydrogen will be placed on the less substituted carbon. Carbon 1 is less substituted because it has just one methyl group. But carbon 2 is more substituted because it has two methyl groups. In terms of stereochemistry of this reaction, we will always get a mixture of syn-addition product and anti-addition product. In the syn-addition product, the hydrogen and the halogen will be attached on the same side, whereas in the anti-addition product, the hydrogen and the halogen X will be placed on opposite sides. Because of this, we could have more than one product sometimes. What determines the number of products we will get usually is the stereochemistry of the reaction. Now, because alkene is flat, the hydrogen halide can approach the alkene from the top and attack that double bond. If this were to be the case, then we will place the hydrogen and the halogen on the same side. We call this syn-addition. We will also have the anti-addition product, in which case the hydrogen and halogen X will be on opposite sides. Also, the hydrogen halide could attack the alkene from the bottom face. If that were to happen, the hydrogen and the halogen X will be attached on the bottom side, both of them facing downwards. And this will be the syn-addition from the bottom face. We will also have the anti-addition product, in which the hydrogen and the halogen X will be on opposite sides. Based on this stereochemistry, we could have more than one product. But this will depend on whether we form a new chiral center or not. How then can we determine the number of products we will get? So there are certain conditions that necessitate the number of products we're going to have. One, if no new chiral center is formed in the product, we will only have one product. And in this case, we do not need to show stereochemistry. If we form one new chiral center in our product, then we will have two products. And these products usually will be enantiomers. In this case, we have to show stereochemistry on the chiral carbon by drawing wedge and dash bonds. But if we form two new chiral centers in our product, then we may have up to 4 stereoisomeric products, RR, SS, RS, and SR. In order to show stereochemistry on the chiral carbons, we have to draw wedge and dash bonds on those carbons. Now let's solve some problems. This question asks us to predict the product of this reaction. To solve this problem, the first thing we need to consider is regiochemistry. So this reaction follows Markovnikov addition rule. This means that the hydrogen will be attached to the less substituted carbon, and the bromine will be attached to the more substituted carbon. If we do that, then we're going to have this product in which the hydrogen and the bromine are now attached to the respective less substituted and more substituted carbons. The next thing we want to ask ourselves is that, does this molecule have a chiral center? Apparently, there is no chiral center here, since there are not up to 4 different groups on that carbon. Actually, there are 2 hydrogens here. So we do not need to show stereochemistry on this carbon. We certainly do not even need to show the hydrogen as well. How about this carbon right here? Is this a chiral center? To do that, we need to identify the number of groups we have on that carbon. These groups are bromine, methyl, and this other group. So these two groups will count as one. So in other words, we have just three different groups on this carbon. That means that carbon is not the chiral center. And since our molecule is not the chiral center, we don't need to show stereochemistry, and we would only have one product. Let's look at another question. Here, we have been asked to predict the product of this reaction. To solve this problem, the first thing we want to do is to consider the regiochemistry of the reaction. The regiochemistry of this reaction follows Markovnikov addition rule, where hydrogen adds to the less substituted carbon and the chlorine adds to the more substituted carbon. In terms of stereochemistry, we would have a mixture of syn-addition product and anti-addition product. In the syn-addition product, the hydrogen and the chlorine will add on the same side. And in the anti-addition product, the hydrogen and the chlorine will add on opposite sides. Now, how can we tell the number of products this will form? We need to look at the number of chiral center we have. Apparently, this carbon is not chiral center because there are no two groups on that carbon. Therefore, we do not need to show stereochemistry. We also don't need to show the hydrogen. How about this carbon here? Definitely, this carbon is a chiral center, and that actually gives you an R configuration. And this carbon is also a chiral center with absolute configuration of S. Therefore, we're going to have these two products as our product. So whenever you do a reaction that involves an alkene and a hydrogen halide, if you form one chiral carbon, you will have two products. Let's go to the next question. This question asks us to predict the product of this reaction. Again, we have to consider the regiochemistry of this reaction. So hydrogen will add to the less substituted carbon, and iodine will add to the more substituted carbon. If we do this addition, this is what we're going to have. The next question would then be, does this molecule have a chiral center? And the answer is no. Therefore, we do not need to show stereochemistry, and we will only have one product. This question asks us to predict the product of this reaction. The first thing we want to do is to consider the regiochemistry of this reaction. Now, regiochemistry is relevant because there is a plane of symmetry in this molecule. That means the hydrogen can add to any of these two carbons, and the bromine can also add to any of those two carbons. It doesn't matter. Next, we have to consider the stereochemistry of the reaction. In terms of stereochemistry, recall that this alkene have a trigonal planar geometry, meaning that its geometry is flat. Because it's flat, the hydrogen and bromine can add to the top. They can add to the top face. If that happens, the hydrogen and the bromine will both be on wedge bonds. That means automatically that the methyl group will adopt opposite stereochemistry, which is the dash bonds. Also, we will form an anti-addition product in which the hydrogen and the bromine will be on opposite stereochemistries. So if the hydrogen is on a wedge bond, then that means this methyl group will be on a dash bond. And since bromine is on the dash bond here, that means this methyl group will be on a wedge bond. Notice that we form two chiral centers in this molecule. Also, the hydrogen bromide can also add from the bottom face. If that happens, that means the hydrogen and the bromine will be placed on dash bonds. Automatically, these two methyl groups will adopt the wedge stereochemistry. And this will give us the syn-addition from the bottom face. For the anti-addition product, the hydrogen and the bromine will be on opposite stereochemistries. And so notice that we have four different products. We have the RR, the SR, the SS, and the RS absolute configurations. You would have 4 stereoisomeric products. The next question is then, why do we have the type of stereochemistry that we have? And why do we also have the type of regiochemistry that we have? To answer those questions, we need to explore the mechanism of this reaction. Here, notice that bromine is more electronegative than hydrogen. That means bromine will pull most of the electrons in this covalent bond towards itself, thereby giving bromine a partial negative charge, indicating that there is excess electron density around the bromine atom. And since hydrogen loses most of the electrons to bromine, the hydrogen will become electron deficient, and we will designate that with a partial positive charge. So what will happen next is that this pi bond will swing out and attack the proton, which will break this bond, and the excess electron will go to the bromine. In this case, we will form a carbocation intermediate, and we will add the hydrogen to the less substituted carbon. And so carbocation will be on the adjacent or on the more substituted carbon. And we will have the bromide ion formed. Recall that this carbocation has sp2 hybridization, and its geometry is trigonoplanar, meaning it is flat. Because it is flat, the bromide can attack from the top face, in which case the bromide ion will be placed on the wedge bond. And here we would have a syn-addition product. The nucleophile can also attack from the bottom face. And if that were to happen, we will form a product in which the bromine will be attached on a wedge, on a dash bond. And this is known as the anti-addition product. And this explains why we have a syn-addition product as well as an anti-addition product. Now, why do we have the type of regiochemistry that we have? Why does the hydrogen always prefer to be added to the less substituted carbon and bromine on the more substituted carbon? So in terms of regiochemistry, if we place the hydrogen on the less substituted carbon, the positive charge will be on carbon 2. But what happens if we place the hydrogen on the more substituted carbon? Now that means we will form a primary carbocation. But remember that primary carbocations are not stable, so this reaction will prefer to go through the secondary carbocation. And this explains why we have the regiochemistry in which hydrogen adds to the less substituted carbon and bromine adds to the more substituted carbon. If you enjoyed this video, please like, share, and leave a comment below. And please subscribe to this channel and turn on the notification bell so you'll get alerted whenever I post new videos. Thank you.